Morning. My name is Nikolay Bachiyski. You can find me at extrapolate.me and on Twitter. In the past 5 years, I have been working for Automattic, mostly on WordPress.com, and now I'm on the super awesome WordPress.com VIP team. During these 5 years, I saw the company scale from 15 people to like 100 now, and I saw WordPress.com scale from about 65 million page views per day in 2007 to around 800 million page views per day now. During this time, I learned a thing or two, and today I'm going to tell you 2 stories. One of them is short, one of them is a little bit longer. First, I'll start with the short story. Before that, meet Deep Pink. And there are some people who don't like foam on their beer. They don't like this. I don't understand them, but there are such people. And Deep Pink's job is beer beheader. He removes the head from people's beer. And he uses a little rake to get rid of the foam like this. And here is the end result, beer without foam or head. In Deep Pink's job, everything below the foam is abstraction. He doesn't really care if the beer is lager or if the beer is ale or if it's stout. He doesn't really care if the glass is white or yellow, if it has a stool or if it's long or a toe. Every single time, he just goes with his rake and removes the foam. One day, Deep Pink decided to read more about the abstraction below. He read about how beer is made, how foam appears, and he learned that foam is just little bubbles of gas, usually carbon dioxide, which raises to the top. And after reading some more, he realized that, oh, if I put a little bit of oil in this foam, the surface tension will decrease, and all the foam will disappear almost immediately. He was thinking, oh, wait, where do I get oil from? And he noticed that his finger was really greasy. Also, you can see he's a pig, so it makes sense. And with this realization, he almost instantly became the fastest beer beheader in the world. He managed to get rid of foam hundreds times faster than everybody else in the world. And all this just with little reading about how beer works. The moral of the story here is that if you're doing something, whatever it is, and if you want to get better, which I assume you do, you will want to know a little bit more about the abstraction below. There are thousands of people about this in programming. I'm pretty sure a lot of you saw Patrick's talk right before me. He showed how if you know how the PHP array is implemented, sometimes you can make your programs a ton faster. Also, if you want to be really good at optimizing SQL queries, you need to know at least a little bit about bit trees. And there are really hundreds of examples like this in programming. I assume most of the people here are web developers. For us, one of the abstractions below is how servers work. And I think that if we know a little bit more about how servers work and how they are set up and why they are set up this way, it will definitely make us better web developers. And here comes the next story, which is how WordPress.com has been scaling all this time. I want to tell you this story because I think knowing a little bit more about this project, and because it's a fairly typical PHP and MySQL application with just a couple of differences, I think this can help you understand your systems better and in the end be better web developers. So everything started a little bit long time ago. We had these users who accessed a single web server who accessed a single database, which was all good. We didn't have a lot of users, and it worked fine. But then we thought, OK, what happens if one of the web servers dies? So obviously, nobody will be able to access the website, and Deep Ink will be really sad. So the solution is really simple. You add a little software load balancer before the web servers. You add a couple of web servers, which run the same code, which is really easy to replicate the code. And in this way, if one of the web servers dies, it will be all good. The other can hold the fort. Then we go to the next problem. What happens if your database server dies? Again, your web servers won't be able to get data from anywhere, and Deep Ink will be, again, really sad. The solution here is the following. Since we are using MySQL, it has really neat built-in replication. So we set up one of the servers as master, and a couple of others as slaves. And the master, in real time, syncs its data to the slaves. By sending all the writes to the master and distributing all the reads between the slaves, both our application got faster. We could add more slaves and thus increase our capacity. And if one of the servers dies, the others can continue working. Everything was really good until we got to the next problem. What happens in the point where your data gets so much that it is not really feasible to fit it in one database server? Currently, we have around 35 million blocks, and a couple of them have gigabytes of data. So it doesn't really make sense to fit all these. I don't know how much data it is, but it's a lot of terabytes into one server. Also, probably it will be pretty expensive and slow. So we decided to do something else. We partitioned our data a little bit so that it can be served by different servers. I'll give you an example. For example, this cluster of a master and a couple of slaves deals with the user's data. This is the user's table and user's attributes. This other master and a couple of slaves deals with one part of the blocks data, like, let's say, the first 100,000 blocks or whatever. Then another cluster of a master and a couple of slaves deals with some other blocks data. This way, we could just partition our data a little bit more and get the whole thing to scale. The only problem here is that we can't do joins. But almost in every application, you have this sweet spot of partitioning where you don't really need joins. For example, in our case, we don't really want to join between tables of two different blocks. Also, it is pretty easy to get away with not joining to the user's table. Another thing about the database, and I will show it with a small example. Let's see what happens when you open a website. Let's say TechCrunch. Here are two fairly common queries you make there. One of them is to get user information, and the other one is to get a couple of posts from the database. How do we know which database server to send this user query to? Or how do we know to which of the many block clusters to send this WP post query to? And our answer is called HyperDB. This is a very small PHP library, and it runs at the application level for maximum flexibility and power. I mean, a lot of people use stuff like MySQL proxy for this, but we wanted the flexibility. And now I'm going to show you how it works with one of those examples. Let's see how HyperDB knows where to send this query to. First, HyperDB parses the query, and it knows that it's for the user's table, and it knows that it's it's a select query. So it goes to its configuration, which says which table in which shard is. Like it says, OK, this is the WP users table. It goes to the user cluster. And then HyperDB can send it to the right web server, which is the second part of the configuration, where you specify a database server, whether you can read from it, whether you can write from it. In this case, you can read but not write, which means it's one of the slaves. And you specify in which data set it operates. So now HyperDB knows that it has to choose one of those database servers from which it can read. It connects to the database server, and this is totally transparent for our application. We didn't have to change even a tiny bit of our application code or SQL queries. Another thing HyperDB does is failover, because if one of the database server is gone for whatever reason, HyperDB can just choose another one from its configuration, and it can successfully complete the query. Again, totally transparent for the application. Actually, the best thing for you guys is that HyperDB is not specifically tied to WordPress. It can work with almost any application, and we know a lot of people who use it in production. And of course, it's open source. I'll publish the slides. You can see the link after that. Now we think we've got the database covered, except for the case where some pages make a lot of database queries. And these queries first take a lot of time and make pages slow. Also, they can hammer the database servers and bring them down. I think the obvious solution for a lot of you is to just cache all these queries and introduce some caching servers so that we don't hit the database each time. For example, we are using memcached, which is the kind of industry standard. And our application, actually the open source WordPress project, supports object caching for a lot of the queries. We also do some output caching, which means that we serve some whole rendered pages, not only the result of specific queries. We do this mostly for unlogged users and for front-end pages because they are fairly static. This is a huge gain. And everything described now works really well for the 90% of the web applications where you have usually less than 10% writes, and you have a lot of reads. So I'm pretty sure a lot of you are working in a situation like this these days. Some load balancers, some MySQL replication, and memcached servers. And this thing is almost infinitely scalable. You can add more resources to almost any of these parts. And this works for majority of the people. There are a couple of things we do on WordPress.com which allow us to fix some bigger problems and scale a little bit more. My first example is, OK, probably all your servers are in one data center. What happens? What happens if this data center dies? I have an example where in 2007, a big San Francisco data center, I think it got on fire, or there was some huge power outage. And some of our biggest competitors went down for 7 or 8 hours, which was huge. And they could do nothing about it. They had zero control over their system. And their users weren't happy at all. That's why we do the following thing. Our infrastructure is in 3 data centers. Of course, where web servers are really easy to put into different data centers. It doesn't really matter. For the database, we do the following. From each master and slave cluster, we have slaves in each of the data centers. So you can always read really fast, and you don't have to do network transfer between data centers. The master for each cluster is in only one, because we have only one master for each shard. But if one data center dies, we can just move the master to one of the other data centers, and the website can continue operating. Actually, data centers go down for us like a couple of times per year, mostly network issues, but it helps us stay online as much as possible. Operating in a couple of data centers here looks really easy, but in reality, we hit a lot of trouble. One of the most notorious examples is syncing cache. I'll give you an example. Both in the green and the blue data center, we have the same cache value for a certain key. Let's say we update the value in the green data center. If some other part of the application tries to read in the blue data center, it will get the stale value. So our current solution is based a little bit on dark magic, but it works. After each request, we get all the cache changes for a page, and we send them to every one of the data centers. So now every data center has all of its cache synced. This solution is still not open source. It's not stable enough, but we are working on it. And soon, there is a lot of interest from many of the large-scale websites for a solution like this, because like everybody uses memcached. And once we have it stable enough, it will definitely be open source. Another thing which is really fun to implement in a multi-data center infrastructure is deploy. There is something strange in our setup. We mostly work from trunk. We very rarely do branching, which is very important for our deploy. Most of the time, if we want a new big feature, we don't branch in the version control. We branch in code. This way, integration is incredibly cheap, almost free. And also, this leads to a lot of commits in our main branch a day. So totally, we have around 100 commits per day. And since this is trunk, it makes sense to deploy after every commit, because you don't want somebody else to deploy your changes after that when he commits something else. And you have to deploy all this code to around 1,000 web servers all over and some other sort of servers. And our deploy is first one click. We have a page where you can do it. This is the button of doom. It has to be one click because it has to be easy. We want people to deploy more. And if it's not easy, if they have to do a couple of things, they won't deploy more. They will deploy less. Also, in order for people to deploy more, we wanted it fast. So this was a huge challenge. And here is an example. Actually, most of us don't use this button of doom thing. We are real developers. We use the command line interface. You can just go and say deploy in the console. So you can see the deploy here took around 8 seconds, which makes deploys a total no-brainer and makes development really fast. We achieved the really fast deploy by having SVN mirrors in each data center. So first, when you type deploy, all the current code and the current revision from Subversion goes and gets synced to all the mirrors in the data centers. And then every server just runs SVN up. There are a couple more optimizations, like we don't always SVN up the whole thing. Like we sometimes keep external stuff like this. But the good thing is that we managed to make it really fast, and the fast and easy deploys are probably the single thing which made the most difference in our developer culture of just moving fast. If I have to be honest, our users couldn't care less about our deploys and how it works. Our users care that if they see the publish button and if they click it, their post will be published immediately. This is the only thing they care about. But man, it's not really easy to make it immediately. So on every single post, you have to push the post to Twitter for the people who chose to do it. You need to push it to Facebook. You need to collect some stats, like number of words, whatever. You need to do some spam checks to make sure this post isn't spam, to block it. You need to index the post for search. You need to invalidate some caches. And in the end, if you haven't forgotten and if you have the time, you can actually publish the post. So our solution to that is also a common architectural thing to have asynchronous jobs. But since we implemented this a couple of years ago, most of the current solutions like Gearman weren't that stable. Also, our situation was a little bit unique. We had some more requirements, and we decided to go with our own thing. The interesting thing about our job system is that it's written in PHP and MySQL only. It doesn't do threads. It doesn't do low-level code. Here you can see how its dashboard. Every job server has a lot of workers, and it spawns as much workers as it needs, depending on the current number of queued jobs. It's really cool. You can prioritize them, and they're incredibly easy to work with. You can just queue a job, give it some arguments, and tell the name job, and it will be run whenever there is time on the job servers. Of course, it has all the priorities. You can defer jobs. Also, we actually use this job system for our cron. I'm pretty sure every one of you has on this web server somewhere at work a huge cron tab with like hundreds of jobs, which have been sitting there for like years. We used to have one of those, but now everybody can go to the web interface and say, oh, I want this job run whenever I want it. We even kept the original cron format. And as I said, it is all PHP and MySQL. It integrates really easy with our system and with any PHP system out there. Again, the best thing for you is that it's open source. You can see the links. You can install it on your own server if you want. And it makes both integration and hacking really easy. Because not every web development company has low-level developers if it needs something custom. And like almost everybody of my colleagues know PHP, so if there is a problem in the job system, they can just go and hack something. I remember one case where we had to send very urgently like 3 million emails to users because we had messed up something. But the thing is that it made it really easy to make some custom priorities for these emails, to make sending these emails fill some cracks in the job system where if a server had some spare cycles, it would send more of those emails. And we managed to send them like in a couple of hours. Okay, probably more like 12, but. So this is all I had. I didn't mention a lot about the infrastructure. So if you have more questions, you would be able to ask now, or later you can find me at the Automattic booth right near the entrance. In the end, I just want to say one more thing, that even if you don't remember anything from my talk, the only thing I want you to get away from this room with is that whatever you do, you will get better if you know a little bit more about the abstraction below. And sometimes it matters if you're sitting on a pig or on an elephant. Thank you.
Yeah, I had a question about your deployment pipeline. So, like, if you're editing some code, and like, I'm just wondering about how the testing works and so forth. Like, if you're editing some code and you have a syntax error and then you commit, like, where is that checked? Like, how does
so first, you can't commit a syntax error. We have a pre-commit hook for that.
I mean, other sorts of testing, and I don't know, you commit something that chews up a lot of CPU on the web servers or something like.
Well,
where does the testing
the
happen?
thing is that if you can, we make sure that you can fail fast. And after if you cause some trouble, because our deploy is really fast, you can fix it as fast. Of course, after you deploy something, we measure and we track whether the CPU usage went up. But if it happens, you can revert the commit within like minutes, very often seconds. And historically, we haven't had huge trouble with that. Both yesterday and today's people stop me and ask about this. And we think that it is better to trust people that they can break something. And this way, they get more confident in what they do. And in reality, they don't break much. I did some calculations. And less than 1% of all commits are actually reverting really on another commit. I can understand the sentiment behind that, oh, if you can break things, people will probably break them. But I don't know, it just doesn't happen so much.
So like even like code reviews,
We do code reviews, but they're post-code reviews. Like, we will review most of the code, or of course, if you're doing something big, it will get reviewed a little bit more. But the whole practice with running a lot of stuff before going to a staging server, having QA, this slows down development a lot. And most of the time, the changes are trivial. Probably 95% of the commits, it's obvious that it won't cause any trouble. But in the normal setting, these commits still go through the normal procedure. The other thing is that we have most of the people develop on something like a staging environment, which has a connection with the production database if you need it. We have these virtual servers which have exactly the same configuration and environment as the production servers. So you actually, in your personal testing, you know that your code runs in the same setting. And since the blogs are totally separate, you can work on a production schema for your own testing blog, and you can break stuff there as much as you want.
Firstly, thanks for a great talk. I love the images. If you were to start from scratch, because I'm guessing history is the reason why you're not doing this, would you use platform as a service? And if not, why not? Because you seem to be doing a lot of extra work here that theoretically the vendors can do for you.
You mean, would I use stuff like Amazon? No, so for our storage, I didn't mention that, but for the user uploaded content, we used to use a lot of S3 and just cache it a little bit with Varnish on our end. But at some point, it gets just too expensive. We have, I don't know, about 2,000 servers. And since we are a big client for most of the hosting company, we get really good rates. And for us, it's just a lot cheaper to run it this way. We rent our servers. We don't even buy them. And S3 and EC2, they scale, but they're really expensive if you compare them to the normal whole hosting costs. So I like the idea. If it was in the very early stages of a startup, it makes sense. Because the moment you get a burst of traffic, you just push down the plus button and you get more resources. But we don't really need that.
Hi, two-part question, if I may, please, as I'm back of the queue there.
You only have about 15 minutes. So
okay,
right.
first one is, what was the cutoff point between platform as a service kind of argument and your own servers?
Usually it's price. Price could be both money and time. I'll give you again an example with the user uploaded content. We used to have all of our content on S3 and then cache it locally. At some point, we started paying huge bills for S3 because we make like hundreds of terabytes or even more traffic per month. We started getting tens of thousands of dollar bills, and we decided, oh, probably it makes sense to invest some time and to build our own thing. So one of the new system guys spent like a couple of weeks, and now we are running all of those on our own infrastructure. We are using MogaOFS, and it works like a charm. But it took us some time to figure it out. We had to find the right Nginx module. We had to fix some stuff in it because nobody before was using it at this scale. But in the end, it was worth the hassle and the investment because we are no longer paying so much for S3. We just have everything as a backup there if everything on our side fails. But we just pay for storage. And if our infrastructure breaks, we can go back to S3 if needed. So we use it as a backup. Go.
Thank you. You answered my second question as well. Thank you.
Hi, I was wondering how you managed your database updates when you need to restructure.
Yeah. First, we keep track of all the database structure in SVN, which we just have a script which goes and collects all the data and tracks the changes. And yeah, unfortunately, we still haven't automated that. It's a huge pain. The biggest trouble there is, actually there are two. One of them is easier to manage, and it is to make your code work with both old and new version of the schema. I thought it would be the biggest pain, but in reality, almost never we had to do very big code changes to accommodate that. So if you want to make a change, make sure your code works with both the old and the new schema. The second and biggest problem is that author table is incredibly slow for big tables. And what we are doing is run the author table on a slave. First, take it out of rotation. Then put it back in rotation, sync the new changes, and then switch them back. But automating this, OK, currently it is semi-automated. It needs some human attention. But it's just too easy to break it to fully automate. And in reality, it doesn't happen so often, so that we invest the time and resources to fully automate that. And one thing that helps is that for smaller changes, we are using something in WordPress which automatically runs the author table. Like you give him the new schema, it figures out the changes, and it just runs the appropriate author tables. This is how the one-click upgrade in WordPress works. You just click and it upgrades.
Just a bit of a question from a WordPress.org point of view.
Mm-hmm.
You mentioned you've got layers of caching. There's quite a few static caching plugins out there.
Mm-hmm.
Which caching plugins do you use internally? Are they open source? And what would you recommend?
On WordPress.com, it doesn't make sense to cache stuff in flat files. We have released a plugin called Batcache, which does also output caching, but in memcached. So we use something like Batcache on WordPress.com, but it's a little bit more complex. But if you have a couple of servers, you should definitely check out Batcache.